Section 1. First question here. Define square matrix. Write a 3 cross 3 identity matrix. So definition of square matrix is a square matrix is a matrix that has an equal number of rows as well as columns. In a mathematics, normally it is defined as M cross M matrix, which is called as a square matrix of order M. If we multiply or add any two square matrix, the order of the resulting matrix remains the same. Square matrix example here. So normally we can example, let's try to find out more examples here. Let me consider 2 cross 2 matrix. A equals to 1, 2, 3. So it's also one of the square matrix. The order of the square matrix is 2 cross 2. Next, 3 cross 3 matrix here. A equals to 2 minus 7, 7, 2, 5, 6, 5, 4, 3. So this is also one of the square matrix. Its order is 3 cross 3. As we can observe from the matrix, here 2 rows and 2 columns. 2 rows, 2 columns. Similarly, here also 3 rows, 3 columns. Write a 3 cross 3 identity matrix. So identity matrix can be defined as an identity matrix of a 3 cross 3 is a matrix which has ones in the main diagonal and the 0 everywhere. The identity matrix of an order 3 cross 3 which is given by. So normally the identity matrix is denoted by capital I letter here, where I equals to, for 3 cross 3, 1 0 0 0 1 0 0 0 1. This is for 3 cross 3 order. Similarly, I equals to 1 0 0 1. This is for 2 cross 2 order. The value of 3a first and then 2b also. So here 3a is nothing but 3 into matrix A 0 2 3 1 here. Let's try to multiply with the matrix A with 3 here. So we will get 0 6 9 3 here. So similarly 2b value 2 into matrix B here, 2 1 3 4 here, 4 2 6 8 here. We need to find out the value of 3a minus 2b. 3a minus 2b here. Somehow we calculated here 3a value as well as 2b value. We can substitute here 0 6 9 3 minus 4 2 6 8 here. So 0 minus 4 6 minus 2 9 minus 6 3 minus 8. So your find after simplifying we'll get here minus 4 6 minus 2 4 again, 9 minus 6 3 3 minus 8 minus 5. So this is our final solution. Next problem here, a equals to 1 0 2 1 3 minus 1 2 minus 1 0 here. Here we need to find out the value of a inverse. Let's try to solve the problem here. We know that a inverse formula is adjoint of A divided by determinant of A here. Now first of all we'll try for finding the adjoint of A. We have to calculate first adjoint of 1 here. So here 3 minus 1 minus 1 0. So which will give here 3 into 0 minus 1 into minus 1. So after simplification we'll get here 0 minus, this will be minus 1 into minus 1 plus 1, again here minus, so which gives 1 itself. So finally we'll get minus 1. So I can say the value of 1 is minus 1 here. So similarly we'll try to calculate the other values here. 0, 1 minus 1 2 0. So right now here 1 into 0 minus 1 into 2 here. So finally we'll get here 2, I can say. So the value of 0 is 2 here. Next value 2, 1 3 2 minus 1. So 1 into minus 1 minus 2 into 3 here. So we'll get minus 1 minus 6, which is minus 7, I can say. Next 1 0 2 minus 1 0 here. So we'll get 0 into 0 minus 1 into 2 here. So 0 minus, this will be plus 2 here, because minus into minus, that will be plus 2. So value of 1 is 2, I can say. So next we are going to be calculate here the cofactor of 1 here. So 0 into 0 minus 1 into 2 here. So we'll get here 2 Next we need to be find out the value of 3 here. Cofactor of 3 1 2 2 0 here. So after simplification we'll get here 1 into 0 minus 2 into 2. So we'll get here minus 4 here. Minus 1 equals to 1 0 2 minus 1 here. So we'll get here 1 into minus 1 minus 2 into 0 here, which gives minus 1 minus 0, which is nothing but minus 1. So similarly other 3 cofactor we need to be find out 2 minus 1 0 as well. So here 2 equals to 0 2 3 minus 1. So we'll get here 0 into minus 1 minus 2 into minus into 3 here. So we'll get here 0 minus 6, which is nothing but minus 6, I can say. So 2 cofactor is minus 6. So minus 1 cofactor here at last. 1 to 1 minus 1. So we'll get here 1 into minus 1 minus 1 into 2 here. So we'll get here minus 1 minus 2, which is equals to minus 3. Minus 1 equals to minus 3, I can say here. So at last we need to find out the value of 0 here. 1 0 1 3 here. So 1 into 3 minus 1 into 0 here. 3 minus 0, which gives 3. So the cofactor of 3 is 0. The cofactor of 0 is 3 here. Now let's try to write all the values. So here we got minus 1, 2, minus 7, here also 2, minus 4, minus 1, minus 6, minus 3, at last 3. But as we know, here the signs in matrix plus minus plus minus plus minus plus minus plus here. So we have to apply the signs also here. So after applying the signs here, minus 1, this will be minus 2, minus 7, minus 2, minus 4, 1, minus 6, plus 3, as well 3 here. So we need to find out the adjoint here, adjoint of A. So we can say we have to change the rows into column and column into rows here. So we'll get here minus 1, minus 2, minus 7, minus 2, minus 4, 1, as well minus 6, 3, 3 here. So here we got the adjoint of A. The adjoint of A is minus 1, minus 2, minus 6, minus 2, minus 4, 3, minus 7, 1, as well 3 here. So here again we need to find out the determinant of A. To find out the value of determinant, 1 0 2 here, 1 3, minus 1 2, minus 1 0 here. Let's try to find out the determinant of the matrix A. 1 into 3 into 0 minus 1 into minus 1 here, minus 0 1 into 0 minus 1 into 2, I can say, again plus 2 into 1 into minus 1 minus 2 into 3 here. So we'll get here 1 0 minus 1 minus 0 plus 2 minus 1 minus 6 here. So we'll get here 1 plus 2 minus 7. So 1 plus minus 1 here. This will be plus into minus, that will be minus 14, I can say. So minus 1 minus 14. So finally we'll get here minus 15. So the determinant of matrix A is minus 15. So we need to be find out the A inverse. The formula says adjoint of A divided by determinant of A. Now let's try to substitute the value of adjoint of A and then determinant of A. So here we got the adjoint of A values minus 1, minus 2, minus 6, minus 2, minus 4, 3, minus 7, 1, 3, whole divided by minus 15. So this is our A inverse. This is our final solution. Next problem. Find the characteristics roots of an A equals to minus 2, 1, 3, 0 here. So first of all, we'll try to find out what you mean by characteristics equation here and then roots here. We need to be remember A minus lambda I, which gives here the characteristics roots here. Now let's try to find out where A is nothing but here minus 2, 3, 1, 0 here minus lambda here 1, 0, 0, 1, where I equals to here 1, 0, 0, 1. This is nothing but identity matrix here. Now we're going to be simplify further here minus 2, 1, 3, 0 minus lambda 0, 0 lambda here. So minus 2 minus lambda 1 minus 0, 3 minus 0 as well as 0 minus lambda. So after simplification we'll get here minus 2 minus lambda, this will be 1, 3 minus lambda here. So minus 2 minus lambda into minus lambda, 3 ones are 3 here, we need to take a minus here, so 3 ones are 3 here, which is equals to 0. So further simplification, which gives here minus into minus plus 2 lambda plus lambda square minus 3, which equals to 0. So after rearranging we'll get here lambda square plus 2 lambda minus 3 equals to 0. So here we can simplify, we can find out the roots here, 3 lambda square, which gives here plus 3 lambda minus lambda, which gives 2 lambda here. So let's try to solve further. Lambda square plus 3 lambda minus lambda minus 3 equals to 0 here. So lambda common we can take, lambda plus 3 minus 1 lambda plus 3 equals to 0. Lambda plus 3, which is a common here. So lambda minus 1, which is left out, which is equals to 0. So we'll get the lambda value as here minus 3 as well as 1. So this is our final answer. So we got the characteristics roots as lambda equals to minus 3, comma 1. Next question. Apply Kramer's rule. Solve the system of linear equation 4x minus 3y equals to 5 and 3x plus 5 equals to 7 here. Let's try to solve the problem here. Let me consider delta equals to 4 minus 3, 3, 1 here. These values we need to be take here, x as well as y values here. Let's try to simplify further. 4 into 1 minus into minus 3 into 3 here. 4 into 1 4, 3 3s are 9 here, minus into minus, which gives plus here, so which gives here 9 plus 4 13 here. We got the delta value as 13 here. Then we need to find out the delta x here. To find out the delta x, we have to change the first column within these two numbers 5 as well as 7 here. 5, 7, minus 3, 1 here. So delta x equals to, I can say, 5 into 1 minus 3 into 7 here. 5 into 1 5, minus into minus plus 7 3s are 21 here. So we'll get here 26 as a delta x. Similarly, we need to find out the value of delta y also. Again, to find out the delta y, we have to change the column here. 4, 3, 5, 7. Let's try to simplify. 7 into 4 minus 5 into 3 here. 7 4s are 28 minus 5 3s are 15, which gives 13. So we got the delta y value. So delta y equals to 13 here. We need to find out the value of x as well as y here. To find out the value of x as well as y, x equals to delta x divided by delta and y equals to delta y divided by delta here. We'll try to substitute the values here. Delta x value, which is gives 26 divided by 13 here. 13 ones are 13 twos are, so we got x equals to 2. X equals to 2 we got here. So similarly, y value, y equals to delta y. So here delta y is nothing but 13 divided by 13. 13 ones are 13 here, which gives 1. So y equals to 1 we got here. So x as well as value, x value is 2 and y value is 1 here. Next problem. A bookshop has 10 dozen chemistry books, 8 dozen physics books and 10 dozen mathematics books. The selling price are 80, 60, 40 each respectively. Find the total amount the bookshop will receive from the selling all the books using the matrix algebra here. So we have to use the matrix algebra. So let's try to find out the solution here. As question itself, 10 dozen, 1 dozen equals to 12 items, I can say. So for that, we have to consider 12 and matrix total 10 dozen, 8 dozen as well as again 10 dozen of mathematics books were there here. So 10, 8, 10 value we can substitute. So again Their selling price are 80, 60 as well as 40 here. 80, 60, 40. Now we'll try to multiply here. 12, 10 into 80 plus 8 into 60 plus 10 into 40 here. So 12, 10 into 80, which gives 800, plus 6 is 48, 0, 0. So 10 into 40, which gives 400. So after solving all the numbers here, we'll get 1680 here. Again we need to be multiply 12 into 1680, which gives here 20160. This is our final answer. So thus the bookshop will receive a amount of rupees 20160 from the sale of the books here. So we can say thus the book shop will receive a rupees of 20160 from the sale of the books here. Next problem, if A equals to 8462 and B equals to 4231, find the AB as well as BA. Also check if AB equals to BA. Given data A equals to 8462, already it is given in the question, and B equals to, I can say, 4231, I can say. Now we have to first multiply AB and then BA, and then we have to check whether both the matrices are same or not. Now let's try to multiply A into B here. 8462 into 4231, I can say. So after multiplication we'll get here 8 into 4 plus 4 into 3, 8 into 2 plus 4 into 1. Similarly 6 into 4 plus 6 into So the given question, next question here, for the given matrix A equals to 2, 1, 4, 0, verify A adjoint of A equals to determinant of A into I, where I is the unit matrix of the order 2 here. Now let's try to understand how we are going to solve the problem here. A equals to 2, 1, 4, 0. Now we need to find out the adjoint of A. So whenever we going to get a 2 cross 2 matrix order 2, I can say, so we have to interchange here first thing, and then this cross diagonal we have to multiply with opposite sign here. So this is adjoint of A, I can see. So similarly we need to find out unit matrix A 1, 0, 0, 1. Now, and determinant of A, let's try to find out 2, 1, 4, 0 here. So we'll get 2 into 0 minus 4 into 1 here. So we'll get here 0 minus 4, which is nothing but minus 4, I can see. Yeah. So here we need to prove LHS equals to RHS here. LHS side A into adjoint of A given. Now let's try to find out here. So matrix A says here 2, 1, 4, 0 here. Multiply with adjoint of A, which is 0, minus 1, minus 4, 2 here. So here we are going to multiply the matrices. First 2 into 0 plus 1 into 4 minus 4 here. Now similarly 2 into minus 1 again plus here 1 into 2, 4 into 0 plus 0 into minus 4, minus 4, this is plus 4 into minus 1 here, plus 0 into 2. Now let's try to simplify here. This will be 0, 0, minus 4 here, minus 2 plus 2 will come here, 0 plus 0, minus 4 plus 0 here. So finally we'll get minus 4, 0, 0, minus 4 here. So the value of A into adjoint of A is nothing but minus 4, 0, 0, minus 4 here. Now we need to find out RHS also. So determinant of A into I can see. So determinant value is here we got minus 4, 1, 0, 0, 1. Now let's try to multiply with a minus 4 here. So minus 4, 0, 0, minus 4 here. So we can say LHS equals to RHS. This is our RHS. This is our LHS. So both are equal.